Hey, so here's our second video of this series on adding and subtracting fractions. So now we're looking at what happens when we've got different denominators. This is going to be followed by a video on the same thing but with some more trickier numbers involved, okay? So this is going to just let us practice how to do them, and then we'll know what we're doing when we get onto those tricky numbers, and they should be much easier for you to do. So the first question I put here, half add a quarter. Now, you'd be amazed how many people will be posed this kind of question in an exam and they start doing all this maths and working out. And there's a real quote actually somewhere that says people tend to leave their common sense at the door when they come into the maths classroom. And it's fairly true. Because when you look at this, a half add a quarter, if you imagine, I know people do use this analogy all the time, but pizza. If you had half a pizza and then you ate another quarter, how much would you have eaten? You would indeed have eaten 3/4. Okay, but people look at it, they see it's two fractions and they start doing all the maths. But that's quite a nice one. You should be able to do that just from what you know from day-to-day life. Actually, I just had a pizza, which is probably why I've got pizza on the brain. It was really nice. Pineapple. I know that's a bit of a debated topic, but I really like pineapple on pizza. Okay, so that's the first one, but let's just have a look at this a little further. That's the reason why I've used this one now, because I think it's something that we know what the answer is, but it's interesting to see how we got there if we were to do it mathematically. So we know we should have got 3/4, but how? How do we know that if these were more difficult numbers? What's the method that we've used? So I'm going to draw them as little pizzas this time, and I've got a half here. Okay, just shading in a half there, and adding to that another pizza, which I'm going to cut into quarters this time, and I'm just interested in one of those quarters. So let me grab another pen. Okay, so the thing we've got to do here, and I think you guys are probably quite happy with the method of this, where we have to find what we call the lowest, write it all out actually, lowest common multiple. Lowest common multiple, and we tend to just shorten that to the LCM. Okay, so we have to find the LCM of these two numbers. But this is why, okay, this is why it works. We can actually cut this. If you think of your pizza and it's been cut in half, you could still cut it into more pieces, okay? And actually, we want it to have the same number of pizzas as this pizza. So what we can do is actually, we can come in here and cut that across the middle as well. So now we've got 4. But we don't have 1/4 anymore. Look at our shaded parts. We've now got 2/4. So what we've got now is 2/4 on that pizza, which is the same amount as a half. It's the exact same. You're getting the same amount of pizza, but we're calling it something else. That's all. We're just going to say, well, actually it's 2/4 instead of a half, because that makes our maths easier. And this one's already in quarters, so we don't even have to do any work for that one. Brilliant, because now we've got what we were looking for before with our common denominators. And now it's the exact same job as what we did on the last video. 2/4 add 1/4 is 3/4. Okay, and we knew that, so it's a nice little proof for us. Right then, so let's try a couple more of these. So the second one I've put down here to do, I've got 3/6 add 1/12. Just pop a line through that. There we are. 3/6 add 1/12. So again, we could draw out our pizzas. Why not? Let's just do that just for this first couple, so we can really get our head around it. Now you get to see the absolute joy of me trying to cut this into 12 pieces equally. That's 4, 5, 6, 7, 8. Not particularly equal. It should be, theoretically. Is that right? 1, 2, 3, 4, 5. Oh no, I need to do one more. There we go. That should be 12 now. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Brilliant. Okay. Not beautifully even, but like I've said, mentioned that website before. Please use that. It will draw these. You could just say, cut this circle into 12 pieces. It cuts it into 12 perfect pieces for you. I'd use that and show you now, but I really don't know how to make my camera show that off the screen. So you're going to have to put up my bad drawings. But we're assuming that these are beautifully even pieces, okay? So we've got 12 and we're looking at one of them. Let's use that one there. And this one here we're going to cut up into 6. Okay, and we're interested in 3 of them. Okay, so there's our 6, 3 out of 6, which, look at that, you should be quite happy to see that now. It's the same as a half, isn't it? Okay, it's the same as a half. We've just given it a different name, 3/6. Cut it into more pieces. Okay, so now we need to find a way to turn these so they've got the same amount in each pizza. Now looking at the numbers, we're looking for the lowest common multiple. Okay, so we want to know what is the smallest possible number that 6 and 12 both go into. So the nicest way I find to do this is to just start to write out the times tables, okay? So 6, 12, 18, 24, etc. We can always extend it if we need to. And for the 12s, 12, 24, 36, etc. And already we're looking for the smallest number that appears in both lists, and we can see 12 is in both lists, and there's nothing smaller than it. The 6 is, but that's not in this list. So that is our lowest common multiple, okay, 12, which means the 6 can be cut up into 12 pieces. That would work. Okay, so what have we got there now? 7, 8, 9, 10, 11, 12. I think that's right. Hang on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Perfect. Okay, so now instead of 3 pieces being coloured in, we've got 1, 2, 3, 4, 5, 6 twelfths. And this one hasn't even had to change, which is nice. Add 1 12th. So from what we already know, 6 12ths add 1 12th are 7 12ths. It's very difficult to say that 1 12th. Okay, so the next 2 examples, I'm not going to draw out the pictures. One, because I'm absolutely terrible at them and I'm concerned that they're probably making it a little bit more difficult than they are helping you. But also, it's not practical to do them every single time for yourselves. All your questions that you're going to look at, it's not ideal to do these every time. Please do them if they help, but going forward, we'll start to use them less and less. So the next one I've got here, we've got 2/5, which is number 3. Can we see that? Oh, it's a little bit high, isn't it? 2/5 plus 6/10. So I like this one. Okay, so we're looking now for the lowest common multiple of 5 and 10. Okay, now some of you might have already seen this, bear with me, or might have already seen what's going on here, but bear with me because I'm just going to write it out because not everyone sees it first time. So we're looking for the lowest common multiple. I'm going to write out my 5s, 5, 10, 15, etc. I'm going to write out my 10s, 10, 20, 30. Look at that, it's 10. There we are. In both lists, we've got 10 as the lowest number. Okay, so we want to turn these into something over 10. Okay, we're going to cut them into tenths. Okay, so, well, the second one's quite nice. That's already over 10, so we don't need to do anything with that. Now, this time we can't just count up the numbers, the number of segments on the picture. We've not drawn a picture. So we need to find our equivalent fraction. So what we're going to say is, what did I multiply 5 by to get 10? Okay, that's what we're looking at, and we multiplied it by 2. 5 multiplied by 2 is 10. And as you know with fractions, we always do the same to the top and the bottom. So if we multiplied the 5 by 2, we have to multiply the 2 by 2. So we get 4 up on the top. So 4 tenths, add 6 tenths, is 10 tenths. And a really nice one, I like this question. 10 tenths is 1, is a whole 1, isn't it? 10 divided by 10 is just 1. Okay, so the last one, and this is a subtraction one, just to show it works in the same way even if we're subtracting. So 7 ninths subtract 1/3. Okay, so this time we're taking something away. Again, we're going to have to find that lowest common multiple. So our lowest common multiple of the 9 and the 3. So we're looking for the smallest number in both times tables. So 9, 18, 27, and 3, 6, 9, 12, etc. And there it is. It's the 9. Okay, the 9 is the smallest number which appears in both lists. So we're going to turn these into ninths. So something over 9, subtract something over 9. This one's already in ninths, brilliant. So we don't need to change it. Now this time we need to see what happened. What did we do to the 3 to get 9? 3 multiplied by what is 9? It's multiplied by 3 actually. 3 multiplied by 3 is 9. If you find it hard to see it that way, 3 multiplied by something, another way to do this is if you do 9 divided by the 3, this number 9 divided by this 3, it will tell you what this number is going to be. Okay, so same, just going back to this one for a moment, 10 divided by 5 is 2. Okay, so it depends which way you prefer to do it. Some people prefer dividing, some people prefer multiplying. It's your personal preference. Okay, so because the 3 was multiplied by 3, we're going to do the same to the 1. Multiplied by 3 is 3. So 7 ninths, subtract 3 ninths, 4 ninths. Okay, right folks, there's going to be one more video, and I expect you've probably noticed on these ones, I've only ever had to change one of my fractions, okay? I've always left it so that one was going to be the same. The next one, they're both going to need to be altered, okay? So there's just a bit more work involved. So just keep your eyes out for that one.